Okay, in this video, I'm going to just give you a little hint about one of the mastering physics problems that is about a couple of boxes that are sitting side by side, and it's asking you to find the contact forces. And all you know, let's call this box 1 and box 2, you know the magnitude of a force acting on one of the boxes. I'll just put it on this side. I don't know which side it's on in your problem. Let's call that, doesn't need a, just call it F. Okay, we'll call it F. And we know the mass, let's say, of mass 1 is 10 kilograms. And we'll say the mass of box 2 is 20. And let's say my force is 100 Newton force. And it's going to ask you the contact force in between these two boxes. And there might be more than one. There might be 3 boxes in there. I mean, there might be more than one set of contact forces. There might be a third box here, and you might have contact forces between 2 of those boxes. Well, the first thing you can do in a problem like this, is you can actually say, apply your A equals F unbalanced over M to the entire system. And what I mean by that is you can find the acceleration of the entire, as if box 1 and box 2 were together as one mass. You can add them together and say my total mass is 30 kilograms and put that here in for mass. Your unbalanced force, obviously the only force that's not offset by something else. These things were all at rest before this force is applied. So this represents your unbalanced force. There's your 100 newtons right there in this particular case. So you'd be able to find the acceleration of the 2 boxes together. That's really important because if you know the acceleration of the set of boxes, the individual acceleration of each one is exactly the same as the 2 of them together because they're going to move as one box as they move across the floor. So now what you'll do after you've found the acceleration of the 2 boxes is you'll draw force diagrams of each individual box on its own. So let's just take box 1 for example. The forces that are acting on box 1, I'm not going to worry about the up and down forces because I know they cancel out. I'm not going to show them in this force diagram. The only force that's acting on box 1 is the contact force between box 1 and 2. So you've got the force of box 2 on box 1. Okay, that's the unbalanced force. I know the mass of box 1. I know the acceleration of box 1 because it's the same as the acceleration of the 2 together. That allows me to find the force, the contact force between those 2 boxes. You'll do the same thing when you find the contact force. Actually, you know from Newton's third law, hopefully, how to find the contact force of box 2 because it's just the force of box 1 on box 2. And I'm going to let you figure out how that's related to this force right here that you're going to calculate based on the method I just told you. I don't want to show you too much. I've gone through quite a bit here, so I just want you to know how to start this problem. And if you have questions, bring them up in class on Monday. Okay? Thanks.